Ceramics are very important materials to help us develop the next generation of sustainable technologies. The reason for that is because ceramics are the best material to resist the extreme environments that are posed by these new challenges. This includes, for example, developing new ceramics for more efficient plane engines, but also developing ceramics for example, fusion reactors. The challenge of ceramics is that ceramics are very brittle, which means cracks propagate very easily within the material. What the community does is we try to develop ceramics which are more tough so they can resist better this crack propagation. How we achieve that is by customizing the microstructure, by designing very fine micro and nanoscale features inside our material that give us an enhanced fracture toughness. The challenge though is understanding how we can characterize and test all these little features that we put inside our material. What is very fascinating about our research at Imperial is how we combine electron microscopy with in situ testing. So for example, we combine the scanning electron microscope SEM with the nano indenter, and when we put all this stuff together, we can then visualize how cracks propagate at the micron scale, and that gives us a lot of information about how the microstructure behaves during fracture. This allows us to combine these two techniques and understand how these micro and nanoscale features in our material give us good properties. We can use this technique to test individual fibers, and that will give us an understanding of which are the best fibers for the next generation of ceramic composites. Thinking about transition to net zero, it's very important that we support and we keep developing new materials, but this is a challenging job. We require all these techniques to be put together so we can develop better materials for transport and energy generation sectors.